Hello, my name is Bryce, and this is Lab 4, oscillations. For this lab, we started by we had a video that we were looking at of a spring, where it was a spring that was attached to this little point here, and it went down, and then the little mass on there was released, and it went back and forth, kind of like that. And we used Tracker to track it, and I'll show you a video of that. And as you can see, it kind of starts out like an ellipse and then moves into a circle type, and then it goes back into an ellipse, and then it rests at the bottom. And we started where the motion started, and then the video ended before I guess it completely stopped. But the initial conditions were that that mass on there was 0.402 kilograms, and I got this data right here from Tracker. As you can see here, that was the X, that was the Y, and put that into the position so where it started, and then since we started at rest, there was no velocity. And important to remember that we considered our system when we were doing all this to be the spring, the earth, and then the ball slash the weight, whatever you want to call it. And then therefore that meant that because of the energy principle, because there's no outside force, there was no work that was being done. So then that means that the change in energy was equal to zero. The data like the calibration length, the time between the video frames that we had to do in Tracker and on all that kind of stuff. It was given in the pre-lecture videos, and so all that data was also inputted into this. We had to calculate K and L naught from our data we got in Tracker, and this is how we did it. This is our calculation loop, and and all that information like the spring constant, the relaxed length, that was all put in there that we calculated. And then this isn't right. It was like 9 seconds that I did it for, but um, and from this we can see that this is how K was calculated, the kinetic energy. It was 1/2 times the mass of the ball times the magnitude of the ball's velocity squared, which is 1/2 mv squared, and then the same for the gravitational potential energy and spring potential energy, and then the total energy, which is all three of these acting together because the system was all three of these. And then, like it says there, and this was the calculation loop that went through every time and calculated a new uh, gravitational. This was the cal This was all the information like the gravity and the spring, the forces for each of those. That was how we did all that in the code. And then we had to add them together to get F net, and then we updated the velocity using F net, updated the ball's position using the new velocity, and then we also had to update the spring and all that because the spring is not a constant force. Had to calculate delta K, delta U grav, and delta U spring, and then we also had to calculate the change in the total energy, and that was plotted on these graphs. This is the change in the energy, which was zero, and then this is the spring, this is the gravitational energy, and as you can see, when the spring is up here, the gravitational energy is down there, which makes sense. And then as you can see that this is oscillating twice, basically, or well, it's oscillating twice as fast as everything else is, the kinetic energy. And then this was the X data that I had, and this is the Y data. I didn't get all of the X data. I kind of stopped it early. That's why I changed the time. And then this is the Y data, and the model and the experimental values were pretty similar for both. Um, and then because we had decided that the system was the the ball,
Because the
like I
system
said at
was
the
the
beginning,
ball,
the
the earth, and
ball,
the spring, there was
the
no outside force, so no
spring,
work being
and the
done,
earth,
so that meant the
then
delta E
equals
equals 0.
0. And then it also wanted us to figure out what the period would be in the using x position and y position data. And we had already calculated using the y, so it was 1.51 seconds. And then x, I used the tracker data again and got 1.61.
This meant the ball was moving in the x direction as much as it was moving in the y.